Hello guys, welcome back to Gedico. This is the first video of the Angular course we are going to start. And this video is all about Introduction to TypeScript, which is the programming language we are going to use throughout this entire course. TypeScript is just a programming language that is extending the JavaScript. So if you know JavaScript, learning TypeScript is rather straightforward and you should be able to learn the key TypeScript features by simply going through the course step by step. In this module, I will introduce you to what exactly TypeScript is and why we might want to use it, what its benefits are, and we are going to explore some of its key features and types, which we use all the time. Now that being said, we will not cover every single TypeScript feature which you see in this course, since you will learn it step by step when we go through the course as mentioned. So what is TypeScript and why would we use it? TypeScript is so-called superset to JavaScript. It's a programming language which builds upon JavaScript, which extends JavaScript you can say. The core programming language is still JavaScript, so the base JavaScript syntax like writing JavaScript code and if conditions, for loops, objects, and all this does not change, but TypeScript adds some more features to the JavaScript syntax. And most importantly, it adds static typing to JavaScript, and that's also where the name comes from, TypeScript. JavaScript on its own is actually dynamically typed. And what does this mean and why it is useful? For this, I prepared a very simple example here. This is a standard JavaScript file and this is a standard HTML file which has no actual content in the body but which imports this script file here. Now if I open this HTML file in the browser, let me copy the path here, go to browser, paste it over here, enter. If you go to the inspect, that is the developer tools, and go to console, I see 7 here in the console, in the developer tools. I see 7 here because if I go to the file again, the JavaScript file, I have defined a function add which is taking two parameters, that is a and b, and then return the result by adding a and b. And in fifth line, I'm just calling this add function with two parameters 2 and 5 and storing the result in constant variable result. And in seventh line, I'm just logging this output. So that's just standard JavaScript, nothing fancy here. Now JavaScript has types. JavaScript knows the concept of types. For example, here the two values which I'm using that are passing here, the 2 and 5 here, are type of numbers. That's something JavaScript knows without TypeScript, right? The important thing is just JavaScript, as I mentioned, is dynamically typed, which means that this function here doesn't expect any particular types. It just knows it will receive two parameters, that is a and b, and it just add them and return them, right? The types for this function are not announced ahead of time. So there are no types mentioned in this function anywhere. Instead, it takes whatever the parameters it gets and tries to execute this code a plus b and return the output. Then it will store it in the result and log the output to the console. And that's how we got 7 there. And that's how this code works with numbers, right? But this code also happens to work with strings also. Instead of this 2 and 5, if I change them to strings like this, 2 string and 5 to string, and if I send these strings as parameters to the function add here, what do you think the output is? Let us see. Let us save it. Go to the console again, refresh it. You see 25 here. Because the plus operator here does not add this 2 and 5 in the mathematical way. It just concatenates them as they both are strings, right? So if it receives two numbers, it will add up and use the result as number, and if it gets two strings, it will add up like it concatenates them and return the output. As I've seen here, 2 plus 5 is 7 and concatenating 2 and 5 strings are 25 with a string output, right? So this shows why JavaScript is okay and great, but why it might not always be the best. Because so if you properly think here, if you use this add function with numbers, it is returning number, and if you use it for strings, it is returning the strings by concatenating them. But this is the error if you use JavaScript in your projects, because this add function is supposed to take the input as numbers and return the numbers by adding them. Instead, it also takes the strings and concatenate them and return. So to prevent the errors like this, we use TypeScript. Now you can tell me, instead of calling this function with the strings, I will just use it with numbers and there is no problem, right? But this is a small project, right, with only 2 files. But what in case if you have a bigger project and lot of files with lot of people working on it? The people may unintentionally call wrong functions and get wrong outputs like this. And JavaScript is not even giving the warning to those outputs. So it will be difficult to scan those errors and rectify them, right? So here the TypeScript comes into the picture. Let me show you. Let me copy this function, create another file, TypeScript function.ts, because we save all the TypeScript files with .ts extension. Save it and paste the function. Let me change this function name here. Now I can use add here. So if you see here, what I can do is I can add type annotations here by simply giving colon and the type of this a parameter, that is number, and I will give same for b also, colon number. So what this function telling me that I will be getting two parameters, that is a and b, which is having only the type of number. So I will be considering only the inputs of type number, and I do not consider any other inputs like string or boolean, anything. So it will take only inputs as numbers and then it will add it, simply return it. And if you see here, it is showing me an error if I hover on it it is showing that augment of type string is not assignable to parameter of type number. That means as I'm sending the string to the parameter type of number, so it is showing me that error. So in JavaScript, you didn't get that error, but if it is in TypeScript, you are getting this error. So our developers will find out the error before you are executing this function or file, and that of course allows us to write better code in the end. Because we can avoid such errors, we don't have to track all of them at the runtime. Before runtime itself, we can track them in the coding part only. And that's why using TypeScript could be worth a thought. That's it for the introduction to TypeScript. We'll see how to install TypeScript. Now go to Chrome, search for TypeScript, enter. You'll get a website here. You can visit this typescriptlang.org. This is the official TypeScript webpage where you can learn more about TypeScript and also install the TypeScript. You can click on this Try TypeScript Now button, and you want to install it on your desktop, right? So you have to click on this on your computer via npm. If you go down here, you see the command to install TypeScript here. That is npm install TypeScript saved up, right? So before installing TypeScript, you have to install Node.js. As you know, the package manager, that is npm, to install the different packages like TypeScript, we'll get it from Node.js. So we have to install Node.js before we installing this TypeScript. So let's go to Node.js website. Node.js, download. Click on the first link. You can click on this button to install Node.js latest version. You can double click on this MSI to install Node.js. In my case, I have installed this Node.js already. You can have few clicks on the next button here, then you will get Node.js installed in your system. Yeah, it is already installed, so it is showing like this. But in your case, you can just click on next and then install. That's it. Okay. After installing Node.js, you go to command prompt. Just try to see Node.js is installed or not. Node-v. You can see the version is 20.11.1 as I installed this version. You can install the latest version also. I think latest version and the version which is on our system is same, 20.11.1. So you can install the same version. Now let's go back to TypeScript. Now you can use this npm package manager as it is also installed through Node.js, and we will install this TypeScript using this command now. So let's copy this command, go to VS Code. This is the terminal that is integrated with this project. So if I want to install TypeScript here, I just want to give the command here. You can install this TypeScript globally also using -g flag here, but I'm installing it for this project only. So I can do just npm install this command here. But before this, I have to create one more file, that is package.json. I can create it using this command npm init-y. So it will create an empty package.json here. This is the file where we install all the dependencies. Then now I will run that command to install TypeScript. Let us paste the command here. Run it. It is installing. Now you can check the package.json. The TypeScript is already there here in the dependencies. Then I can say it is installed successfully, and package.json is also being created, and you can see the TypeScript version here, right? With that installed, we can now evoke the TypeScript compiler. As you have learned, TypeScript is a superset to JavaScript, extending the JavaScript syntax with those extra types. Now the important thing to note here is that TypeScript code doesn't run in the browser. So if you want to try to execute the TypeScript code in the browser, it will fail obviously. So therefore we need to compile TypeScript to JavaScript, and during that compilation process, all our type annotations will be removed, because the JavaScript doesn't know the type annotations, right? So if I go back to IDE here, so if we convert the TypeScript to JavaScript file, it will warn us with potential code problems if we haven't spotted them in the IDE before, like the one we are getting it here. And then the compiled code, that is the JavaScript file, can be run on the browser. Now to evoke this compiler, we have to run a command. Let's go to the website again. You can see this npx tsc. We have to run this command to evoke this compiler and convert the TypeScript file to JavaScript file. Copy it. Let us paste it here. Run it. You see the JavaScript file is not created here, because if I run this command just like this, npx tsc, then it expects a TypeScript configuration file in that project folder here. That tells TypeScript which file to compile and converts them to the JavaScript file, right? We'll add that configuration file later, but for the moment, we can run this command slightly modified in order to create the JavaScript file. So in order to create the JavaScript file without using that configuration file, I just want to do like this. Along with this npx tsc command, I have to give the TypeScript file name, TypeScript fun.ts, right? Press enter. So now in this case, the TypeScript file got converted to JavaScript file. You can see it is created here. So this file got compiled and created this JavaScript file. If I open this JavaScript file here, if you see in the terminal, it just warns you because of that error, but still it generates the JavaScript file here. It will create the JavaScript file without any types. If you see here, A and B, it doesn't have number types, annotations, and it also changed the constant result type to var here, right? Because it still also compiles the code such that it runs in the older browsers as well. That is something we can be overridden using TypeScript configuration file, but we don't have such a configuration file yet. So therefore we have this code change as well. But of course you see that other than that, it's same code that is written in the TypeScript file, right? And hence I will convert my strings here to numbers. So I will not get that warning and will just compile without any errors. Save it and just run it again and compiling it again. If you see now the error went off. I didn't get any errors in the terminal. And if you go to the JavaScript file here, it is the same code as earlier, but without any errors. I got this, and it changed the strings to numbers, obviously. Now let's import this file in the HTML. So instead of the JavaScript fun, I will be giving TypeScript fun.js, right? And then let's save it. Let me run this file in the browser. Copy the path. Go to browser, paste it in the browser. Inspect. You can go to console. You see 7 here. So I got 7 here again. But now if we continue working on the TypeScript file and then compile it to run in the browser, now we actually protect ourselves against errors like we had it before, the errors we are getting while we are running the add function, right? Thanks to TypeScript. Let us deep dive into some core basics you need to know about TypeScript. Let me create a file here in the VS Code, basics.ts, like this. I will start with some basic types. You can work within the types, but you will need all the time to work within the TypeScript. They are the primitive types, which we know from JavaScript. Those are numbers and strings, also Boolean, right? These are the primitive types. And then of course we also have complex types like arrays and objects. Arrays and objects. We'll also discuss about function types and much more about some parameters of the function types in the later videos. But for now, let's start with the primitive types here. The primitive types we have here are numbers, strings, and booleans. Also null and undefined, also some of the symbols. For now, we'll concentrate on these common types like numbers, strings, and booleans, null and undefined as well. But these are the important ones to know. So let's say if I have a variable age, we have to define it like this, let age, like that. And if I want to make it clearer that this age should be a number, then I have to give this age a type annotations. I should define it as a number variable. So in order to do that, I have to give colon and number here, like that. So it says that this age variable should be of number type. So let us initialize this variable age equal to 12, like that. So it doesn't show me any error. And you can also use floating types also here. .4, it doesn't give any error because the floats and the decimal places all comes under this number only. But if we try to assign a string here, then it will show error. So it should be only of number type. This is what we saw before in this TypeScript file with these parameters as well, right? We don't have to do this in the second step. We can also just initialize it in the same line itself, like this, right? This is also possible. Now let's create another variable, let username, which is of string type. And I can initialize in the same line, like username is code, like that. And there is one important thing to note here is, it is a lowercase number and lowercase string to define the primitive types. If we use the capital number and capital string here, instead of the lower characters, these are turned into objects. So if you use uppercase N and uppercase S, that is the starting letter of these types, as capitals, then it is objects in JavaScript. If you want to use only the primitive types, then you have to use smaller case, that is lowercase. You have to use the lowercase N and lowercase S in order to use the primitive types. So let me show you Boolean type example also. Let is Boolean. It is a Boolean type. Let me assign it to true or false, like that. Let me assign it to true or false, like that. And we can use it in the program as we go. These three are the core primitive types which we can assign in this case to variables. Now as I mentioned, there is a null and undefined types also. But let's say I have a variable 1 which I set to null. And if you want to change that variable 1 afterwards, it will show me error because we should not change that null variable, and it is not too useful to write in our program, right? We just use it in different way that we'll be knowing in the later videos. But let's focus on these primitive types and complex types now. So coming to the complex types, the arrays and objects here. Let's start with arrays. So let me create a variable called hobbies. In this hobbies, I just want to store not only one hobby, I want to store the number of hobbies I have, right? So it should be the array of hobbies, the array of strings, actually. So I can give like this, string, like this. So I have to define the type, that is string. So and I have to give opening and closing brackets here, which defines it as an array of strings. So it will tell the TypeScript to store the array of strings in this hobbies variable. If you want to store the array of numbers, you can just give number instead of the strings. And if you want to store the array of boolean, you just give boolean like this. Okay. And if you want to initialize it, you can do like this. Hobbies equal to swimming, cricket. So if I try to give any other types instead of strings like 12 here, it will show error because I defined the type of this hobbies to array of strings, but I have given 12 here, which is the type of number, right? So it will not allow us to give numbers or any other boolean types. We just have to enter strings as we defined it like this. So that's how we set up array types here. Now we can also set types for entire objects also. Let's say I have a variable called person here, and I want to store all the person's information inside this variable, like the name and age. Let me do this. Person equal to name, carry code, and age. For example, let me take 12. I want to be able to store something like this, the name and age, that should be stored in this person. Now of course this works, and by default allows me to store any value in this variable, because if you hover on the person, the type of this variable is any. The default type assumed is any type. If we do not set any data type here, then it will be defaultly assigned to any type. It means that I can store any data type inside it. So if I define a variable here like this, which simply tells TypeScript that I don't want to tell you anything about the type of value stored in this variable, that is person, and anything is allowed. And of course this is a fallback type, which you typically should not use, because it kind of defeats the entire purpose of using TypeScript in the first place. We are using TypeScript that because we can able to use these data types. So if you do not use them in the TypeScript, then no point in using the TypeScript, right? So if you do not use them, you are basically using the standard JavaScript instead of types. So if I want to store a person with a name and age, I should not define it like this, because afterwards if someone changes it to person equal to let's say any boolean type, like is he the employee of the company, like that, true or false. It is allowed here because it is not showing any error. But I don't want such type of extra variables here. Instead, I just want only name and age. So in order to do that, I have to define it here, the data types here. I can define the type of this variable like this, u colon, and I'm using this flavor brackets. Inside this dictionary, I am setting the variables types I want to initialize. Let's say name, it should be of string type, not the object string. So let me use lowercase string, and also age of number, right? If I see now my ID is showing error here, it is saying that we should not use this employee variable here because the allowed variables are name and age of string and number type, right? So we should not use this, and it will not allow us to use this other than the name and age variables. So it will allow me to initialize the person with name and age because it is having the same structure as I have defined it here. Let's say if I want to store different person's information in a list, but this is only one person's information, right? So I just want to define a variable which can store an array of person's information. So in order to do that, let's say I'll be storing that information in a people variable, and I have to define the data type, but it should be of the same data type of person. Let me copy it, paste it over here, and I just don't want to store only single person's information, but instead I want to store the number of different persons information. So basically I need an array of persons, right? So I just have to give brackets here, the open bracket and closing bracket, in order to make it as an array. And this array will have the data types as defined here with the name and age as string and number. So now we can store different types of persons information in this people variable instead of storing only one person's information. So that's it for this video. I have explained about primitive types and arrays and objects here. Type inference, union types, and type alias. Let me start with type inference first. In all these examples I have defined here, I always declare these variables with a type assigned to it, and then I set a value to it, right? Let me show you what is type inference now. Consider another variable here like course. Let course equal to TypeScript and Angular tutorial. So I consider a variable called course. Inside this course I'm storing a string TypeScript and Angular tutorial, like that. Now after creating this variable like this, I want to store a number in this course variable, like the course ID, right? Let the course ID be 1 2 3 4 5. But if you see here, I'm getting an error because the type number is not assignable to type string, right? But why am I getting this error even though I didn't define any type in the course here, right? Well, here the TypeScript used its powerful feature of type inference. By default, TypeScript tries to infer as many as types as possible. So it will try to know which types are used where without explicitly stating those types. Like you have written the string here, like you have assigned a string here to the course variable. So without mentioning it is a string variable like string type, the TypeScript automatically infers this course variable as string type variable. So which means you need to write less code. I could also set my type here like string. That would not be wrong, but it's redundant, right? Because if you immediately initialize this variable with a string, the TypeScript will automatically enforce this as string type variable. And if you set a number, then TypeScript will automatically enforce as a number type variable, like that. So it is not mandatory to define the types here if you are initializing the variable in the same line, right? It will be redundant code. And it is considered a good practice and a good idea to embrace the type inference feature of this TypeScript. Unnecessarily you are specifying the types here, you can use this type inference feature. Let me give you another example for the type inference here again. Let number of courses equal to 10, like that. If I want to initialize this number of courses with any string 10, it is showing error because this number of courses variable is already assigned to type number by using type inference. But if you try to assign a string afterwards, it will show error because this type number is not assignable to type string, right? So this is what type inference is. Now let's discuss about union types. Until now we only had this scenario where we took only one type for one variable, right? Each variable is having only one type. For username it is string, for age it is number, and is boolean it is boolean, and hobbies it is array of strings. These all variables are defined with only one type. But sometimes you want to allow multiple different types to a single variable also. Yes, that is also possible. Like in this case, if you see, let me comment out this. In this course variable, it is logical to store both a string and also the ID, right? Whenever I want to refer the string, I can store the string, and whenever I want to store the ID, I can store the ID, right? It really depends on what you're building. So it might be the case there should be a variable with having two types to store both strings and ID. So there might be the case where one variable should be storing the string and number also. Like in this case, my course variable should be able to store the string, that is TypeScript and Angular tutorial, and ID of that course 1 2 3 4 5. So here we want this course variable to be stored more than two types, right? So now in this course variable we want to store more than one type, right? And this feature is called union types. A union type is a type definition that allows you to store more than one type in a single variable. So how can you do that? After this variable, by adding a colon and then your first type, that is string, and also the second type, that is number. This should be separated by a union operator here. These two types should be separated by a pipe symbol like this. So you want to store a boolean also, you can just use like this and boolean, right? So now if you see here, the course variable is storing ID here, but we are not getting error here because we have defined it in the way it can store more than one type. Let me store a boolean type also. course equal to true. Here also I'm not getting any error because I have defined boolean also in this allowed types. You can also do this by union types feature, that is let username equal to get code. If I hover on it, it is a string variable because I have assigned it in the same line, right? So by using the type inference, it is being converted to string variable, right? But I can do like this, giving a colon string. Also I want to store a list of usernames in this username variable, so I will be giving a pipe symbol here and then string and then opening and closing brackets. So now what happens is this username can be able to store both string and also the array of strings. That is, I can store a single username here and also list of usernames. Pretty helpful, right? So this is what union types here. This is how we use these union types in TypeScript. Now the next thing we are going to discuss here is type analysis. Now the more TypeScript code you are going to write, the higher the chances that at some point you might be repeating some type definitions. And we are actually already doing this here. See, these people, we have defined name and age, and also for person also we have defined it here, the name and age. We are repeating the same structure here and here again. But this is an array, and this is for storing only single person. This is for storing the list of people. This is for storing the list of persons. But they are using the same definition here, right? So this is duplication, right? So to avoid this duplication, we can use this type aliases feature. You can define your own base types like this, which is more complex type definitions, and then use type aliases instead of this repeating entire type definitions for the variables which are required. So before we use this object type for the first time here, we can define such a type aliases by using the type keyword. That's a keyword which doesn't exist in the JavaScript, in the standard JavaScript, but which is added by TypeScript instead. Now after this type keyword, you use any name of your choice. Like here I'm using type person, like that. And after the equal sign here, I will be having the type definition. Let me copy these things. So I have defined a type here, my own type, with a name of string and age of number type. So you can have the type definitions like this in TypeScript, but when you convert this to JavaScript, this whole thing will be thrown out of the window when the code is compiled. So now instead of this type definition here, I can use this type person like this, and I can replace the whole definition with type person type. I can use the same thing in this people type definition also. I can replace the type definition with type person whenever I encounter this type of structure. So instead of those type definitions, I can use my type alias here instead. So therefore they are all still the same type, but I have defined it only once here. So it can reduce the things I have to repeat for the type definitions. I don't need to repeat it all in all the places where I need this type definition, right? So this saves us a lot of typing work and therefore make our code more concerned about functions and also generic types. Let's start with functions and types. And I'm saying functions and types because when we work with functions, there are different places where we use types also. We'll be assigning those types to different variables. Let's start by defining a function here. Function. This is the keyword to define functions in TypeScript, also JavaScript. Then I'll give name to our function. Let us say add. I'll create an add function which adds two numbers. So it will take a and b as two parameters, and it will return the numbers by adding them like this. But if you see the parameters we are passing it here, a and b, they are of any type, not specifically defined as number, as we discussed in the first video. So I'm assigning the types to this a and b parameter, like a colon number and b colon number. Now if you see this function definition here, it is taking two parameters a and b and returning the number a plus b by adding the numbers a and b. So I defined a type here for a, that is number, and for b as number. But there is one more type here which is inferred by using TypeScript, using the type inference feature. But I didn't give the type to this. I'm talking about the return type. We can see the type it infers if we hover it on the add function here. We'll see the type definition for the add function. Here it is taking a and b as numbers, which is we defined it here. But after this definition here, there is a colon and it is showing it as number. But this is not defined from us. It is automatically assigned by using type inference feature in TypeScript. We can also set the return type explicitly here by giving a colon here and say it as number. It is also possible, but I would say this will be redundant as it is inferring the type automatically. Not only single type, we can also give union types, like give a type symbol here and then string, like that. So we can able to define a union types here or only single type, that refers to the return type. So if there is any special reason to do it, you should do it, but other than it is not necessary to do this. It will automatically infer the return type for this function in TypeScript. Now I want to discuss about some special return type in TypeScript. To know that, let me define another function here. Function print something. This function is to print something to the console. So I will take a value here which is of any type, and I will just print this value here, console.log value. So I'm saying this function to take this value and just print it in the console. That's it. So I'm not returning any value from this function, I'm just printing this value. So now if you hover on this function here, it says the return type as void. So this is the special return type I want to make you know about. In this case, it says that we are not returning anything, right? Nor number, string, or boolean, right? So it's just taking it as void. So that means we are not returning any type. It's just void. It's not returning anything. And one more rule to know about defining these functions are we should not use the keywords that are present in TypeScript or JavaScript to define these function names here. For example, if I want to make it print, as there is a built-in function already in the TypeScript that is print, we should not use the same keyword to define a function. This is the basic rule. So that's how we define the functions, parameters, and the return types here. Now let's discuss about generics. Let me consider an example here, like a function. I will be defining a function. Insert at beginning, right? And this function takes an array and a value. And I will define the input parameters types as, like for array, it can be of any type of array, and for value, it is of any type. So it might be strings, numbers, or boolean types, whatever. It will take just these arrays and the value here that is given from the function call. So whatever it takes, I just want to create a new array from these values, like constant new array equal to, I will be using the spread operator to copy the existing array like this. That's a standard JavaScript feature that is also supported in TypeScript also. And I just want to append the value at the beginning of this array. So value, comma, and I will copy the whole array here, and then I will just return this array. So basically what this function doing is, it's just taking an array and a value, and the value is inserted in the beginning of the array by taking the copied values from this array and creating new array and then returning this new array. So let me call this function. I'm defining an array here, like constant array1 equal to 1, 2, 3, 4. Then I'm calling this function insert at beginning. I'm sending this array, also an value like 0, like that, and I'm storing the returned array, that is the new array here, in some other updated array. Let me take another array here, updated array, like that. So the output for this array will be 0, 1, 2, 3, 4, right? This should be the output. But the problem here is, if I hover it on the updated arrays, it is of type any array. So an array full of any kind of values. TypeScript doesn't pick up the thing that it's an array full of numbers, because if you hover on the function, it has array as any type and value as any type, and it returns also an any type array. So our updated array is not an type of array of numbers, it is a type of any array. So I cannot say, oh, this function will only allow numbers and it will return only numbers. Even though if I send strings along with this number array, it will got updated in the array, right? Like if I send any string carry code like that, it will append the carry code at the beginning and it will update the array like this. And after this, if you want to make some operations on this updated array, like updated array dot updated array, in first position I can see it is a string, right? So I'm taking the first position. In the first position I can see it is string, right? Carry code. So I'm taking the first position here, and then first string I have an operation like split dot split, like that. I can do like this, but this will not throw any error here in the compile time. But at the runtime, if you didn't send any carry code string here, it will throw an error because the first index is only number, right? Number doesn't have a function called split. So as TypeScript doesn't know that first position is string, as a developer we know that, but the TypeScript doesn't know it. So to overcome these problems, we have a feature called generics. So with this feature called generics, we can convert this function into generic function. That is, we can use a special syntax here after the function name. We can use these angular brackets like this, we can add them, and inside these angular brackets we can define a generic type. Like in this case, let me take it as T for type, but you can use any identifier of your choice. And instead of this any, I can use it as T type, and also for the value also we can use same T type. So what this function basically says is, I'm taking an array of T types and a value of T type, and I'm returning a value array of T types. So if I send an array of numbers here to this function will infer the type by looking into the values inside this array. If it is number, then this T type will be assigned to number, and the value should be number, then the return type will be number, right? If it is strings, then this value will be string. We have to send it as a string, otherwise it will throw an error, and the return type should be a string. By the minute I defined it as generic function, you can see here the split function is showing an error, because if you hover on the updated array, now it is showing the number as its type. That is the number array. Now it's showing number array as its type, because we have defined the function as a generic function. And as I said, we are sending the number array here, and the value is also of number type, so it is returning a number type array. So the updated array is of type number array, and we don't have any split function for the numbers, so it is showing error here. So before compiling itself, we can find the errors using these generic types instead of getting them in the runtime. So this is a use case for generic types. If you have any doubts, you can comment down below. I will be explaining them. Please subscribe and check out other videos in the channel. Thank you. Thanks for watching. Some interfaces with TypeScript. And we know classes from modern JavaScript already. You can define blueprints for object with the help of class keyword here, class, right? And again, this keyword is supported in TypeScript, but it is actually also supported in modern JavaScript also. Now with classes, as I just said, you can define blueprints for objects which you plan on initiating. For example, here I could create a person class, or let's maybe create a student class student, like this, and then you can add properties and methods to this class. So for example, here we could say that every student should have a first name property, first name, and we can assign types to these properties to make it clear that this first name property should have string type, string, right? And then we may also have a last name of same string type. Here you should use semicolon instead of these commas, as you are defining variables inside this class, and one more variable called age, which is of number type, right? And maybe a courses array, which is an array of strings like courses string, and we'll give this parenthesis to make it array of strings. Now with that, we define such a blueprint here for the student class. We can also define a constructor function to this class, or constructor method, you can call it as. Let me create a constructor here. You can give constructor like that, and let me take the first name here, like first, it is of string type, and you can take the last name of string type, and then age of number type, and then courses of array of strings, like that. You have to give curly braces here, and that's how we define this constructor here. As you see, I have the same argument names as I have properties thereafter here. We could then set first name like this dot first name equal to first, then this dot last name equal to last, and then age equal to age, then courses is equal to courses. I should convert this capital S to small s, because this should be normal string, not the object strings, right? The primitive type. It should be of primitive type string. Now we got rid of this error here. So by creating this constructor, when we create an object of the student class, this constructor will be called by default, and we should pass all of these parameters to that object while we creating that. Let me create an object here. I will store the object in constant student variable equal to, I can use new keyword to create new object and give the class name that we defined there, student, and we have to send all the arguments, like the first name, let me say it as KD, and the last name, it is code, and the age, let us take it as 25 for example, and the course is array of strings, right? So let me take it as TypeScript, right? Like that. So that's how we define our new object here. After you created this object, we can access those variables using the dot operator. You can click on dot here, student dot, you can see all the parameters here, age, courses, first name, last name. You can access them by using this dot operator, right? Not only the parameters, you can also access the methods inside this class, which we'll be creating now. So let's create a method inside this student class. Let's say the enroll method, enroll, which allows us to enroll the student to a new course, and therefore we accept a course name as an argument here and then add it to the courses array, right? So let's consider a parameter that is course name, which is of string type, right? Then we can use this dot, this courses variable, then push of this course name, like that. So what this function is basically doing, this is taking an argument that is of course name, it's just taking one course and pushing it to the courses array. That's how you add a method to a such class. This is method shorthand notation. You have the method name here and the parameter list here, therefore the function body inside these curly braces. So it's basically defined like regular JavaScript function, which is important difference is there you will be using the function keyword here like this. It is not required here. Without any such function keywords, we can create this method here, right? So now we can call this method here student dot, we can call this enroll method, and I will be sending a course name that is Angular. So if you try to access this variable courses, that is array of courses, array of strings with different courses, now you will be getting a list of courses. In the first position it will be TypeScript, and the second position it will be Angular, right, as I am doing this addition here. Now the special thing about TypeScript and classes here is that we have defined all the properties here, and this class will have this in advance, and we will be setting the types for those different properties also. In standard JavaScript we won't do that, right? We would not have these property assignments. Instead, properties would be added just setting them inside this constructor. With TypeScript, you can define them ahead of the time, including their types here. And also, it's very important with the TypeScript, you can control whether a property or a method should be publicly accessible or if it should be private variable, right? Like if it is private, it can only be accessible inside this class. And if it is public, I can do this student dot. So you can see the variable names and method names. By default, they are all public. But if you want to make them private, and can be used and should be used inside only the class, you can also do that. So by default all these properties and methods are public, because by default I can access them all, right? But we could say that courses should be private by adding the private keyword in front of the property definition, like private here. right? So if I want to try to access that courses variable here using dot notation, it is not visible here, you see, because it is not a public variable which can be accessible outside the class, right? And then we could of course add another method here like list of courses, like that, and in this function we just return the list of courses that the student has enrolled. And doing like this will not give much gain. Instead, I will be sending a copy, that is the slice of this array. So it won't be sending the address of this variable where the user can change the values inside this courses variable outside the class. Instead, it will send only the copy of this array, right? So if I try to access this courses variable here, it will show me an error as it is not a public variable, it is private, so it should not be accessible. But instead, if you want to access all the courses, you can just call this function list of courses and you can just print it to get the list of courses the student has been assigned to, right? And one more thing to learn here is instead of defining these properties here and the types, you can add these modifiers, these accessory keywords in front of these parameters in the constructor method itself. Like you can remove all of these here and you can just mention it here like public, and you just change this name as first name and last name. You have to mention it as public. Age is also public, but courses it is private, right? So I will mention it as private, and that should be set up as public properties, and they are private in front of all the parameters which should be set up as a private properties. Then you don't assign values like this here, so I just remove them. If I format this, Shift or F, now this will lead to the same result as before. This is a shorthand notation for defining certain properties of this class and their types, right? So this will allow the user to assign those values to those properties when the class is being assigned here. Now this is all about classes. Now let's try to learn about interfaces. Interfaces is a feature that's only exists in TypeScript, not in the JavaScript. And any interface code which you write here, you will see it in a second, will therefore not be compiled to JavaScript. Now what are the interfaces? In their most basic form, interfaces are really just object type definitions. So we could say that we have a human object here. Like you can use keyword interface and the name for the interface, like let's say human, and a curly braces after that. So I'm just considering a human object here in our application, and we can define it like this. After these curly braces, we can define the structure we want for this human object. Like this human may have the first name with a string type, right? And then let's say age with a number type. And let's say this human has a method called greet, in which he will be greeting all the members, right, other humans. It is of void type. Let me do this. I am not writing any code inside this structure, I'm just defining the types here, right? We just add the method definitions here, not the actual code. We just add the types to this first name and age. We don't assign the values here. And this interface will take no parameters as an input and returns nothing. It's just be used to define an object type definition. Now we can use this interface, as I just said, as an object type. So if I have a new variable called KD code member, right? This KD code member, I want to store some information about this KD code member. I could make it clear that this should be a type human. So I can make it as human type by giving this. Let me create this variable, let KD code member with a type human. I can give the type as human. So this make it clear that this should be the type of human, like this. And now if I want to assign a value, I'm not allowed to store it. Like if I want to store some number like 45, it will show an error because this is an object type of human. I'm not able to store any other values other than the same structure it has here, right? So I have to store the same structure here. So I'm giving you curly braces here, and I'm assigning the first name here. It will also give the auto completions for you. First name as KD code, and then age, let's say 25. And then I have to complete this greet function also, that is greet method here. Greet, I'm not just writing anything inside here. Like even if I don't write any code inside this greet function, I should just implement it, so it will get rid of this error here. And now this works because this object which we store in this KD code member will fulfill all the structure requirements for this human, right? So we use interfaces to define object types like this, but we could also do this with a type keyword, right? Using type here and type human equal to, like this we can also define a type. But why we are using interface instead? Why do you think? Why do you think we use this interface if we do the same thing with the type keyword? Because it can be used as an alternate to the type keyword, right? But there is a difference. Interfaces can be implemented by only classes. Interfaces can be implemented by these classes. And when they use this interface, the classes are forced to have the structure defined by the interface. Now this might sound very abstract, but this can be helpful if you are building an application with multiple developers, and if you want to ensure that there are certain classes written by another developer has a certain structure, because you as a part of working your needs, you should be in need of that structure. So you need the class to have certain method. For example, in this case, you will want to have this greet function for every human, and if you define an interface here and make a class implement this interface, that other developer should implement all these methods or assign these variables inside this interface, because it's a must, because you are making the class to implement this interface, right? So that's the difference. you will force to add those certain feature to the class we define, and it will work with a lot of classes when we are working with Angular. Let's say I have a class called querycode. For this querycode, I want to implement this interface humans and give a curly braces here. So there is an error here. If I hover on it, it says this is incorrectly implements the interface, as querycode is missing the properties of human interface, right? The first name, age, and greet function. So whenever I create these variables and the methods, let's say first name and then age and then the greet function, so I'm not implementing them, but these must be defined inside this class in order to get rid of this error, because as a developer I need this querycode class to implement this human interface. That the other developer must define all of them, because he doesn't have other choice to get rid of this error. So by using this interface, I can define the structure of the certain class and I can make it correctly implementing this interface. So they don't just act as object types, instead they also force us to set up this certain structure for our classes. So this is the advantage of these interfaces in TypeScript. We use them in the Angular application project we are doing in this course a lot. So that's it about the classes and interfaces in this video. If you have any doubts, please comment down below. Please subscribe and check out other videos in the channel. Thank you. Thanks for watching.